You've touched on two very interesting points there as well that came up in a recent Q&A from the community. One is interoperability, and second one is hack-proof and cybersecurity.
Yeah.
Be super interesting, I think, for the people watching if you could say a few words about each of those.
Yeah, so the internet computer looks like a computer, it smells like a computer. You can install software on the internet computer, you can execute that software, it'll store data and so on and so forth. But it's not really a computer. It's a kind of virtual computer created by this massive network of full nodes that run the DFINITY protocol. What this means is that this internet computer is deliberately, in many respects, very simple. That's all you can do. You can install the software, you can run the software, and it can store data. With a traditional computer, you can sort of open up a terminal window and sort of poke around and try and escalate your privileges and maybe modify the contents of the password file or something. That's just not possible on DFINITY because all that stuff doesn't exist. I mean, it's a virtual computer. Really, it's a figment of the protocol execution. Very different to a traditional physical computer with an operating system, or even a virtual computer built on such a thing like an EC2 instance. So the platform is hack-proof. What does that mean for people building on top? Okay. Well, at least you don't have to worry about the underlying platform being hacked. You do have to be cautious, when you build a software system on top. If you create a function that anybody can call, right? Well, anybody can call it, right? You also have to make sure that your users who have some kind of public key identity don't lose their private keys, because that would enable someone to impersonate them and access. Right. Notwithstanding all of that, obviously, so long as your software doesn't have bugs, and so long as your users don't lose their private keys and so on, your systems will also be hack-proof. You don't have to worry about firewalls or anything like that, just the computer itself is inherently hack-proof. So that obviously moves the game forward in a major way, in my view. And especially when you can combine that with technologies that preserve the privacy of user data, you begin to see how this could really be revolutionary in a number of different fields. And we're all aware of horrendous hacks that have occurred. For the Office of Personnel Management, for example, losing pretty much all of these sensitive details of people who have applied for jobs in the US government that have some kind of security sensitivity. So, and that's just, there's Equifax, and it just goes on and on forever, all these hacks. And I think, we're seeing a sort of collapse of the, traditional IT stack with all its complexity, in the sense that, it just can't provide people with the security and the resistance to hacks that are necessary, and it can't look after sensitive private data. Mm-hmm. So I think anyone wanting to build a new software system will definitely find all of these features, security, availability, interoperability, and privacy extremely attractive. And so in that sense, the internet computer is just trying to reinvent how we build software and host software. But there's also another interesting dimension to it, and that is that we also enable the creation of completely new kinds of software. The most important is what we call autonomous software. Now, autonomous software is a system that exists independently of its creator or any other, in inverted commas, owner. Typically, an autonomous software system will be built with a governance system, which is controlled by tokens. And through this governance system, the autonomous software can update itself. So in that sense, we're applying the open source software development model to a running internet service. So at the moment, open source is only good for updating some software package. There are a number of reasons we think this will eventually be huge. One is that you can provide guarantees about user data. So you can have an internet dating service that kept all of the chat database in a crypto lockbox. And we have a way of doing that allows algorithms to be run on the chat database. So for example, looking for matches between users who maybe have common interests by analyzing what they've said, while ensuring that the contents of that chat database can never be, extracted, right? They just always stay in the crypto lockbox. So, an internet dating app built on DFINITY using the autonomous software model, the, open source business model, if you like, can guarantee to its users, look, don't worry, you're going to be on this for a few years, and then maybe you're going to settle down, right, and get married or whatever it is. The contents of this internet, these embarrassing chats you've had are never going to come out, right? So that's just a very simple example of how autonomous software can provide some interesting guarantees to
the end user.
But actually, there's another really important piece, and today's internet has become very different to the internet of old that was so successful. So. Back in the day in the 1990s, there was a lot of debate about whether something like the internet would succeed or private networks like AOL or CompuServe. And in the United Kingdom, British Telecom, which was a sort of monopolistic telecom provider, was trying to persuade the government that they should be allowed to create this thing called the information superhighway and connect everyone in the UK up to their own private network. And so there's going to be the internet's dangerous. You can't control what's on it. We're going to create this wonderful walled garden and carefully curate all the content and so on. Thankfully, it didn't come to pass. Now, the reason the internet succeeded, there were two reasons the internet succeeded. Because it was an open and decentralized network, an open and decentralized network without any central point of control. All of these ISPs could build out the network. So it grew very, very fast. No one needed permission, right? And in the UK back in the 1990s, there were sort of hundreds of individual ISPs who built out the network and provided access to people. The internet was able to grow very quickly and provide access to lots of different people through enlisting the help of lots of different parties. That was the first thing. The second thing was that the internet was an open network. So that meant if you were an entrepreneur, you could create a new service and connect it to the internet with very low entry cost. And if you were successful, you didn't have to worry about a competitor degrading your access to the internet or degrading your service in some way. And in contrast, if you wanted to build a service on AOL, well, number one, you'd have to persuade AOL that your service was going to be good enough that they should, list it. That's going back to the dating app example. In the case where AOL then decided that they wanted to run their own dating app because internet dating is very profitable, guess what? Your dating app would be right at the bottom of AOL's homepage all of a sudden, right? Yep. And so it wouldn't be a level playing field. The internet, by contrast, well, you didn't have to get anyone's permission to create a new service. And once you created that service, you're on a level playing field. Nobody could sort of degrade your access. What's happened though recently with the internet is, it's become very monopolistic, and there's been a lot of consolidation around these, monopolistic internet giants whose services have become platforms. And you need to use these platforms to gain access to users, user data, functionality, markets, and all kinds of things. You're not really building directly on the internet anymore. You're needing to build against these platforms that are run by these monopolies. Mm-hmm. Now, this has led to something called platform risk. And this has been killing, investment into new internet services. So I'll give you a really simple example of platform risk. Zynga. It was a very successful games company. They created this thing called Farmville, grew to 200 million users. It was a social game built on top of Facebook. They, IPO'd, and they were, I think, worth $10 billion or something crazy. Then, unfortunately, one day, I don't know if it was Mark Zuckerberg or someone else at Facebook woke up and said, look, we don't like the way that, these mechanisms that these games are able to use to promote themselves, and maybe we'd like to push some of our own social games in and all this kind of stuff. And they just changed the mechanisms. So overnight, that was pretty much the end of Zynga, and it's never recovered. And that's an example of platform risk. I actually personally knew a company because some guys from the sort of Cassandra, this distributed database I was involved with, and it created like a communications map of your organization, both internally and externally. Anyways, the point was, in this communications map, the nodes were people, and if you hovered your mouse over one of these nodes, the profile of that person would pop up. Unfortunately, of course, that profile data came from LinkedIn. So this company was doing great, amazing team, great vision, became a unicorn, were doing very well indeed. And then, one day in 2015, LinkedIn decided that the only people that were going to be able to access the LinkedIn profile data were going to be Microsoft and Salesforce. Pretty much overnight, this amazing company had the rug pulled from under it, and they ended up having to sell themselves for less than a quarter of their valuation to Salesforce. One of the two companies, one of the two monopolies, I should point out, that still had access to that API. Now, if you're a VC and you're looking for new companies to invest in today that want to build internet services, typically they're going to need to use the data in one of these pre-existing monopolies, right? Or the functionality, their functionality or something. And if you're a VC, you're like, well, yeah, I can see you've got a great pitch and this makes absolute sense, but what happens if one of these platforms, do a Facebook or a LinkedIn, right? The first thing is we think that with the internet computer, right, people can build things like an open source LinkedIn using autonomous software. And the open source LinkedIn built using autonomous software will be able to provide guarantees about the APIs that give other entrepreneurs access to the profile data. And this is going to do two things. Firstly, it's going to mean that other entrepreneurs now have the security they need to start extending the system and building on top of that API. And secondly, it's going to give investors the confidence to invest in the ecosystem. So you get what I call mutualized network effects. The open source LinkedIn will benefit because of people building on top and the people building themselves on top. So these kind of mutualized network effects, I think, are going to drive forward the open internet ecosystem. And in the end, I think it'll fly past the monopolistic ecosystem, and people will remember a lot of the internet giants of today in the same way as we remember AOL and CompuServe.
I think speaking about these platform risks is a great place to loop back to something that we wanted to talk about earlier, interoperability. What's your vision for how different chains are going to coexist and how are they going to interoperate with each other?
So I'm a bit of a heretic. I mean, most of my views are heretical in the blockchain industry, but I tend to believe that in the different categories, a leader will emerge. And the world doesn't want lots of leaders. That's why, by the way, internet monopolies exist. Once you're on Facebook, you don't use another social network because everyone else is on Facebook. And it's easier to interact with other people on Facebook.
They've grown so big and captured such a big part of the market.
Totally. So you get a sort of to a phase shift, if you like, in the development of these ecosystems. So originally there were lots of social networks. Originally there were lots of search engines. But at some point, various dynamics kick in that drive consolidation.
So you think there's going to be one big player, right, that captures a big part of the market, but at the same time, like if we compare it to social media, again, there's Facebook, which is kind of like your online profile, but there's various like niche players like Instagram for pictures or YouTube for videos. Let's say the same thing happens in the blockchain or decentralized space, and there's going to be these niche players for certain types of applications or smart contracts. What is your vision for how these services are going to interoperate with DFINITY and connect to DFINITY?
Let's say we arrive in a world where you have a few category leaders. I think Polkadot and Cosmos working hard to address the interoperability needs that will exist. I also think there may be yet unforeseen mechanisms that will allow these different networks to talk to each other.
Right, because all the infrastructure that we're seeing in the space is just being developed right now. There's nothing that has been established for years and years. And what is one application or one type of application that you are excited about that should be launched on the DFINITY internet computer?
So, there are so many things you can build on the internet computer. What we really want people to do is start reinventing the internet in open source, autonomous form, right? So, I mentioned the internet dating app earlier and how you can provide users with amazing guarantees about their embarrassing chats, never leaking out into the public, and guarantees about how their private data will be used. But, there are so many cool things you can do. We want to see the creation of Dmail, like, DFINITY Mail, right? We want to see the creation of, an open source Salesforce. Anything that exists at the moment can often be reinvented as an open source business, right? Where you have, an inbuilt governance system that updates the software that's controlled by tokens. And that's why we have the DEF, the DFINITY Ecosystem Venture Fund. And, there are more venture funds in the works to fund people who want to build on top of the internet computer. I also want to see, of course, municipal councils reinventing their systems for collecting parking ticket fines and things like that.
Cool, what an exciting time to be alive. Dom, I know your schedule is very busy. Thanks a lot for taking the time and coming here, answering questions. For everyone that's still watching, if you're excited about what we are building, check out dfinity.org/jobs. There's lots and lots of interesting roles and positions that we're hiring for right now. Also, if you've liked this video, please subscribe below. And if you have questions for Dom or anyone else on the team, leave them in the comments and I'll make sure to mention them in one of the upcoming episodes. And with that, thank you guys, and we'll talk soon.